Fred and Francine are at camp. They are challenged to melt an ice cube without touching it to the fire. Both of them pick up a metal rod, put it into the fire, and touch their ice cube with it, hoping that it will transfer the heat through the rod and melt the ice cube. Fred found a short rod. Francine could only find a longer rod. Whose ice cube will melt faster? We're now talking about conduction. Conduction is the transfer of thermal energy directly through a physical material. Conduction depends on a couple of things. The heat transferred increases if the area of the rod increases. The heat will increase if the difference in temperatures increases. So for example, if this rod started at a colder temperature, it's going to be a bigger change between the temperature of the rod and the temperature of the incoming heat. So you would have an increase in heat transfer. The heat transfer decreases if the length of the rod increases. So unfortunately for Francine, finding a longer rod is bad luck for her, because with an increased length in the rod, she will have a decreased heat transfer. And finally, some materials transfer heat more easily. So because the length of his rod is shorter, Fred's ice cube will melt faster. Now let's summarize all those statements into an equation for the rate of heat transfer. The rate of heat transfer is also written as Q over delta T. That's heat over change in time. This equation is on your AP Physics 2 equation sheet, but you should know what the pieces are. K is the thermal conductivity of the material. So if you have a material that has a high conductivity, it's going to have a high rate of transfer. So something like metal will have a higher K than an insulator. A is the cross-sectional area of the material. So a larger cross-sectional area will have a larger rate of heat transfer. L is the length of the material. A larger length will have a smaller rate of heat transfer. Delta T is the temperature difference across the material. So the difference in temperature from one point to the other. If it is a large temperature difference, it will have a faster rate of heat transfer. Q is the amount of heat transferred. Finally, delta T is the time interval. So rate of heat transfer is for when there is contact and heat is transferred through a material. But there are two other ways to heat something. Convection is the transfer of thermal energy by the motion of a fluid. If you have a pot of water on the stove and the heat is applied to the bottom of the pot, we have direct contact with the bottom. That's going to be conduction. But then it will heat the water inside. The water inside will heat up and it will rise. And the cold water will fall. The fluid will move in a circle. All of the water will heat up by convection. The thermal energy will cause the water to move, the fluid to move, and transfer thermal energy into the fluid. We also have the term convection oven. A convection oven does basically what a pot of boiling water does, except the fluid is going to be the air inside the oven, and that air is moving, and as it moves, it transfers heat throughout the oven. Radiation is electromagnetic waves that transfer energy from the object that emits the radiation to the object that absorbs it. So when you go out in the sun and you feel the sunlight, there's no fluid that's passing the heat. You're not in direct contact with the sun, but you have the electromagnetic waves from the sun. They come from the sun through the vacuum of space and will warm the earth and you if you're outside in the sun. Those are the three main types of heat transfer.